Hello everyone. In this video, I'm gonna go over a problem from our homework assignment again. It is gonna be a regression tree problem from using the Orange software. Um, so I already checked the answers though, but like I just want to go over this problem. Um, in here, the instructions are given, the variables are given. We're trying to figure out the best regression tree, and then try to conclude some kind of like results from that. So it's kind of like trying to again uh, in the similar problems we try to predict the credit score over here based on the variables given, like inquiries or credit usage, total credit, collection report numbers, missed payments, home or not, and credit age, and so on. I'm going to show you how to work this out on the regression tree. First of all, the model is given for us. I downloaded this for you. It took a little bit of time, so that's why I downloaded first. It says in the first part, you need to make sure that you're going to be using this correct file over here, which is the credit score file. And from here, we're going to use the full model, but here when you select the columns on the data, make sure that individual variable is moved to ignored, and credit score is your target variable. So this should be moved over here. You can just drag it. It's really simple. Like credit score, you can drag it here, and then individual variable should be on the left side ignored. And then data sampler, it says, if you look at here, it says just use the 100% of the data for training and validation. You can go into the data sampler here and make this 100, and then sample data. It's going to be using the full one. All right, we got that one. And then we're going to go to the model selection. In model selection, it just tells you that we're going to use a 10-fold cross-validation experiment and in this one, and it just tells you what you need to do. Like you need to select induced binary tree, and then deselect these two items, and then minimum number of instances and leaves should be 1, and then do not split subset smaller than is to 2. So how can we do this? So we're going to go into here, into model selection, and as you see, I'm going to be choosing these three. Do not choose the last two. Set this one equal to 1 and set this one equal to 2, and then it's going to compute for us here the test score and test, and then the score after it completes the run. Um, it's a little bit slow because of my computer. A lot of things are open. Zoom is open as well because of this recording. But I'm going to show you that now. If you go over here, you're going to see that the RMSE, the root mean square error, will be 66.831. This is how you get that one. So as you see, all the instructions and given here, you're using like the full model here, and number of folds is 10. That's what it says over here. It's just like 10-fold cross-validation experiment, and then you just choose which tree model that you're kind of selecting in there, and then the root mean error you got is 66.831. So it says here the minimum number of instances and leaves, you can just choose different values in here, and it says find the best one for you. So best one will be the one with the lowest RMSE. So you can test different ones. For example, you can test 10 and 50. Here you can just say I'm going to choose this one 10, and I'm going to choose this one as 50, and run this, and then see like what your RMSE score is. So based on this one, you see we got 55.218, which is better than the full version. All right, like the full one. And over here, if you go into the list, you can just check them, but the best number that I got is 55.091 from 10 and 150. So you're going to be like a little bit of guess and check over here, but it's not really too many. You can just check that, but 10 and 150 will give you the best RMSE. In my case, in your case, it might be different, but check that one. Like I go in here, I'm gonna say, hey, I'm gonna choose the model here with 10 and this one being 150. Do not split the subset smaller than 150, and the number of instances and leaves will be 10. And you run this one, and you will see that this is going to give you the smallest number, which is 55.091. So okay, so I mean these are like all different kind of like regression tree versions that you're choosing, and the best one will be the one that you have the least error, like root mean squared error in there. So I hope this is clear. This is the first part of it, and then you can just see that's kind of like RMS is lower for the pruned one, which is the second one, and then the tree indicating that it generalizes better. So I like the explanation for this is um, it should be the overfitting on the full. All right. You may just yeah, you can just check that part. It's really pretty kind of like straightforward that you can get this from like this one. RMSE is lower for the pruned one, and then it's better for the out of sample data. And a likely explanation for this is like you have an overfitting on the full one. All right, so you can just check that part, and then it's again a little bit slow, and then we're gonna be moving into so that's what you will have, because like that means you're overfitting on the full. You have like too many kind of like you're considering every possible like kind of option in there. That's why you're getting an overfitting over there. But when you prune the tree, when you use those like leaves and branches, like smaller leaves and like subsets, smaller, then that makes it a better model. All right, it's like smaller and smaller makes it better in this case. We just avoid overfitting. Now here we go. This is the one how you read this one, but you need to make sure that you just choose here the best one. You go to tree and all data here, and then over here you have to make sure that you're going to be using the actual the one that we have, and it's 10 and 150 was the best one. And then we're going to be going into tree viewer here. Here we go. So here we go. Here's how you read it. So it just starts with the missed payments. If you look at this one, it just computes with the missed payments. And the left side is less than or equal 1. The right side is greater than 1. In my problem, it says the number of missed payments is 0. Collection reports is 0. Missed payments is 0. 25% is the available credit. 5 credit bureau inquiries, and then 17,500 total available credit. So we're going to go through this one by one, kind of like branch by branch, so we got this one second from here. Let me just zoom in a little bit over here. All right, we got this one. This is now missed payments list or equal 1. Now on the left side it says the next one, next split is time on the job. So time on the job for this individual is 7 years. So that means I'm going to go here, the one with the 7. So here less than or equal 9. So this is good. I'm going to the left side. And the next one is credit usage. My credit usage is 0.25 on this problem. You see 0.25, 25%. So I'm going to go to 0.25, which is on the left side, less than 0.3. So time on the job is less than 9, missed payments less than or equal 1, so I'm on the correct track. Next one, it says next split is college collection reports. There's none, so it's going to be 0, so that means I'm again following 0 because this says it's less than or equal 0. Can you see the splits that I follow? And next one, it again goes back to credit usage. So it's kind of like grouping the data set based on these variables and these conditions. Now, credit usage was 0.25, so I need to go to right side this time because it's 0.2. See, credit usage, it says greater than 0.2 and less than or equal 0.3, so I'm on the correct track right here. And then from here, it says missed payments, again, it was 0, so I'm going to choose the left side. You see, missed payments less than or equal 0, credit usage between 0.2, 0.3, collection. So all those conditions are satisfied. It's kind of like you're following the logical statements. And then the next one was time on the job. Time on the job was 7 years, so I need to track the right side. Can you see that? Here we go. Time on the job between 6 and 9, missed payments less or equals 0, credit usage between point 0.2 and point 0.3, and collection reports less or equals 0. So I'm on the correct track. Next one is total credit. My total credit was $17,500, right? $17,500. So that means I'm going to be choosing the right side, and that's the end of it. So I'm just done with that. I went through all the branches, and I just stop at that at this group. And you see, according to this group, according to this this kind of like these conditions, my expected credit score is 671. In the previous one, I find 671.2. It worked. It says like point 0.2 over here. 671 also works. It should work. But you can just check that it's 671.2, and I got that 671.2. I want to tell you this: your numbers might be different, but again, here you are choosing a lot of different conditions. If you use the full tree version, everything in there, the RMSC is you're expecting a bigger one, and you're in this case we're just calling it an overfit on the full one. The pruned one is better because we got a better RMSC, and the best one that I got was 10 and 150, and as I said, lower RMSC means you have a better model, and based on that model, that's the way I track it and then get the actual estimation for the given conditions. I hope this makes sense. I hope this is clear. I just wanted to go over this example. Thanks for watching. Bye.